Okay, so for part A, we want to show that the distance between the points r1, comma theta 1 and r2 theta 2 is given by the square root. So the way I'm going to do this is just assume r1 comma theta 1 is somewhere in the first quadrant. It doesn't really matter where it is, but you got to put it somewhere. And I'll just say r2 theta 2 is in the second quadrant. So keep in mind that we always start from the origin. We go out r1. So this is theta 1. The angle is theta 1. And this here, this length from that point to the origin is r2. And that entire length, or that entire angle, is theta 2. So the difference, so if I was just looking at this angle right here, that would be the difference between theta 2 and theta 1. Okay, so I want to find the distance between these 2 points, which comes down to finding this length. Okay, so we'll call it C. And the reason I'm going to call it C is because I want to use the law of cosines. So let's say I have some triangle. I'll make it similar to what we have. A, B, and C. Law of cosine says C squared is equal to A squared plus B squared minus 2AB times cosine theta. And that theta is the angle between A and B. For us, we basically have R2, R1, C, and theta 2 minus theta 1. So all we have to do is just substitute it into this formula. C squared is A squared plus B squared. It doesn't matter what you say A and B are, but I just said this is A and this is B. Minus 2AB. A, we said it's R2. B is R1. Cosine. And then theta is theta 2 minus theta 1. Right, that's the angle between R2 and R1. So I take the square root of both sides, and just to keep it the same, I'm going to switch the R1 and R2 like in order, the order of R1 and R2 rather. So I have R1 squared plus R2 squared minus 2 times R1 R2 cosine theta 2 minus theta 1. So this is exactly what you get for part A. So part A is complete. Part B, describe the positions of the points relative to each other for theta 1 equals theta 2. Simplify the distance formula for this case. Is the simplification what you expected? Explain. Okay, so if theta 1 equals theta 2, what happens to this angle here? That means that theta 2 minus theta 1 is 0. So that implies that they would overlap each other. So like, think of it as they would be on top of each other. Okay. So how would you simplify the formula? Well, if we use the so if we have that theta 2 minus theta 1 is 0, we're going to use this formula. C is the square root of R1 squared plus R2 squared minus 2R1 R2, and then cosine of 0, right? Because theta 2 minus theta 1 is 0. Cosine of 0 is just 1, so this is R1 squared plus R2 squared minus 2R1 R2, square root of that, which I can write this in factor form. It's just R1 plus R2 quantity squared. I'm sorry, R1 minus R2, which is really the absolute value of R1 minus R2. So you may be wondering why it's the absolute value. So in general, if you have the square root of x squared, this is the absolute value of x, because the square root function is always greater than or equal to 0. So let's say if it was a square root of negative 9 squared, you would not say that this is negative 9. You would say that it is positive 9. So therefore, you have to have the absolute value. So like the square root of negative 9 squared will be the absolute value of negative 9. Because the absolute value guarantees it's always positive, or greater than or equal to 0. Which we know that the square root function, the range, is greater than or equal to 0. Okay, so that completes part B. And I guess, actually, we're not, let's see. Let's revisit it. Is it simplification what we expected? Yes. Because you're measuring the distance from the origin. Like the r is the distance from the origin, so you're just subtracting the two distances. And yeah, so that explains it. So those 2 points will be collinear because it will fall on the same line. Okay, for part C, simplify the distance formula for theta 1 minus theta 2 equals 90 degrees. Is this simplification what you expected? Okay, so let's go back to our picture. Actually, maybe we just redraw it. So theta 1 minus theta 2 is 90 degrees. So keep in mind, this is what we had. So this thing is now 90 degrees. This is R1, R2. This is C. This was R1 theta 1, R2 theta 2. So if this is 90 degrees, that means you get a right triangle. So how do you find the hypotenuse of a right triangle? You just use Pythagorean theorem. So you would expect to get the Pythagorean theorem, right? So C would just be the square root of R1 squared plus R2 squared. So yeah, this is not surprising. But if you want to use the formula that we found over here, you would just set, so you would just have C equals the square root of R1 squared plus R2 squared minus 2R1 R2 cosine 90. Now cosine 90 is 0, so this thing cancels, and you're just left with the square root of R1 squared plus R2 squared. Just like we said over here. Okay, for part D, we want to come up with 2 random points. So I'm just going to pick 5, negative 30 degrees and 7, 55 degrees. So we know C is the square root of R1 squared plus R2 squared minus 2R1 R2 cosine theta 1 minus theta 2. And R1, so we'll call this R1, this theta 1, this R2 theta 2. So R1 squared would just be 5 squared. R2 squared is 7 squared. Plug in R1 and R2 again. And then we have cosine theta 1, which is negative 30, minus theta 2, which is 55. Take the square root of that, plug it in the calculator, and you end up getting 8.24 as your answer.